Hello students, today we are going to take up the oxo acid of phosphorus. So this topic is important. 1-2 structures can be asked in your exams. So let us start with a very good thought. Face your fears. Sometimes we will come across any situations that we feel that it's difficult to overcome. We are having fear from that situation. We don't want to face that. So one thing is that until and unless you face that challenge, you are not going to cross it. Otherwise it will be a barrier for you for the whole time. So we need to face our fears to overcome it. So learning outcome from this session is you will be able to know about the OXOACIDS of phosphorus. You can draw the structures of phosphorus OXOACIDs and similarly preparation of phosphorus acids. So this is a summary of OXOACIDS of phosphorus. If we talk of hypo H3PO2, ortho H3PO3, pyro H4P2O5, hypophosphoric acid H4P2O6, ortho phosphoric acid H3PO4, pyrophosphoric acid H4P2O7, metaphosphoric acid HPO3N. So first and foremost thing we need to be aware of that how to calculate the oxidation number. Now first if you talk of phosphinic acid or hypophosphorus acid, oxygen is having -2 oxidation number, 2 into -2 -4 and hydrogen 1 plus 3, so it would be -1, so phosphorus would be having +1. So you can take X and solve that and you will be able to solve it very clearly. And similarly of 3 -2 6, -6 plus 3 3 and it will be 3. And 5 into -2 -10 plus 4 -6 and 2x is equal to 6 is equal to x is equal to 3. So this way you can calculate all the oxidation number. I will suggest you to find all the oxidation number by writing by calculations. Okay, now how to draw these OXOACIDs? How to draw? So please try to understand that there is some common bonds are there, like PO bond, phosphorus oxygen double bond. This is common, every time it will be there. And another common bond is POH. Always you will find that POH and PO bond in all. You see the structures, every structure will contain PO and POH bonds. Okay. Now the third type of bond is either POP or PP or PH. These are three types of bonds rather than the PO and POH. So in regard to preparation, there are methods like phosphorus alkali, P2O3, water, PCl3, phosphorus acid, red phosphorus alkali, P4 water, heating phosphoric acid and high phosphorus acid bromine heat in a sieve tube. So let us discuss in detail that how we can draw structure. First thing is basicity also. If you draw the structure, you will find that POH, one POH bond is there in case of hypophosphorus, and here 2 are there, here 2, 4, 3, 4, 3. So as the number of POH bonds are there, it only can release H plus. That is known as ionizable hydrogen. So ionizable hydrogen is 1 in case of first, so therefore monobasic. If 2 ionizable hydrogens are there, so dibasic. So here you can find that this is dibasic, and here is tetra. 4 POH bond is there. So it means POH bond is deciding the basicity of any oxo acid, not the actual hydrogen. Because here you see the hydrogen will be more. PH bonds are also there. So hydrogen are 4, but does not mean that it will show tetra basicity. Okay, so you should be very careful about the structures. So one structure is aware, then only you can tell that this is monobasic, dibasic or tri or tetra. Okay, so maximum is tetrabasic. Now how to draw structures? So before starting the structures, we should be aware of that what the basic structures are there. Basic structure, you should remember the two basic structure. One is H3PO3 and second is H3PO4. So H3PO3 is orthophosphorus and this is orthophosphoric. Always remember pyro word is used when two molecule of ortho is joined together and water molecule is removed, that is known as pyro. If you see, if you take orthophosphorus, combine means you make it 2. 2 means H6P2O6. So H6 if you remove water, so H4 P2 and 6 will change to 5. So this is pyro. It means two molecules of H3PO3 with the removal of water you will get pyro. Similarly, if you are having phosphoric acid ortho, if double it H6P2O8, so H6 means 2, H4 P2O8 was there, so it changed to 7. So pyro. Now ortho and pyro case is clear to you. So pyro is obtained when two molecules of ortho is combined with the elimination of water molecule, then pyro you will get. Okay, and it is to be noted that the oxidation state may vary or may remain same. Like orthophosphoric acid was having 5 and here also it is 5. Here ortho was having 3, here also 3 is there. Okay, so now the word we are using is hypo. Hypo is always oxidation number from the parent would be less. See here hypo plus 4 and here is plus 1. So now if you are talking of hypophosphorus acid, if you take orthophosphorus acid, if you remove oxygen, then you will be getting the hypophosphorus acid. Similarly, if you are having hypo here, so you take pyrophosphoric acid, remove water, you will get, remove oxygen, you will get hypophosphoric acid. So here oxidation number for hypo is less than the corresponding ortho or pyro. Okay. So meta is obtained when water is removed from H3PO4. If you remove water from that, you will get metaphosphoric acid. It will exist in the dimer form or polymer form. So now let us draw the structure on that basis. These are the basic structure we should remember. This you cannot afford to forget. So here you know that one PO bond here also, and one POH bond is compulsory. Balance H3PO3, so HOH this way, and all these molecules will be in tetrahedral arrangement. Okay, so how to obtain? You know that P4O6 is anhydride of phosphorus acid. So when you add water, you will get phosphorus acid. Similarly, P4O10 is the anhydride of H3PO4. When you add water, you will get that. So here also same thing, PO bond, OH bond and OH. Here is only one. Now ionizable hydrogen are 2, so basicity is 2. And here ionizable hydrogen 3, basicity is 3. Now, we are having orthophosphorus, we want to convert into hypo. I already told you that one oxygen will be decreased. So how? So one oxygen if you are decreasing, it will become H. So any H you can change, any oxygen you can move, OH here or here. So you will get this. This is very easy to now make the structure of hypo. So formulas also and the equations also you should be aware of. P4NaOH give rise to Na2O. H3PO2 plus phosphine. This is the method of preparation of hypophosphorus acid, and the oxidation state is +1. As we earlier discussed that hypo will be having lesser oxidation number as compared to the parent orthophosphorus acid. Now we are talking of pyro. Pyro, I told you already, two molecules of phosphorus we will join a removal of water. Let us say this molecule of phosphorus and this phosphorus, and removal of water takes place, and we got here this structure. So now you see OH full-fledged OH will go, and OH will go from here, and H we can remove from here. So you combine these structures. If you combine, let us say OH is gone from here, H gone from here, this combine, and this will be getting. So this structure is now the structure of pyro, and you can see from here that if phosphorus acid, what is orthophosphorus acid is having this structure, and now we are getting this pyrophosphorus acid as this structure. Okay, so this way we can get the structure of phosphorus acids. Hypo will be having lesser oxidation number, pyro is oxidation number remains same. Now here, if you are talking of phosphoric acid, you are having phosphoric acid. If you are joining two molecules and removal of water, you are getting pyro. So how to simple this is 2 molecule H3PO4, removal of water H4P2O7 we got. So here this is peroxide linkage is here, this is a peroxide linkage. Now if you remove water from that you will get meta. Okay. Now this way pyro we have discussed that from pyro you can change into hypo. Pyro is H4P2O7, removal of one oxygen, this oxygen peroxide linkage we have removed, and you got here H4P2O6, that is hypophosphoric acid. As we told earlier, hypo will be having oxidation number less than the pyro or ortho. So here also +4 oxidation number is there. You can obtain this hypophosphoric acid by using the phosphorus oxide of lead, treating with H2S, and you will get that H4P2O6. Now this is already we have discussed that water we can remove, and this will exist in the form of polymer. Okay, so this was the structures of oxoacids. So mainly what we have learned is phosphorus is tetrahedral surrounded by other atoms, and all the phosphorus acid will contain one PO bond and one POH bond. Other than that, PP bond and POH bond will be there. And oxoacid having phosphorus in the lower oxidation state contain either PP bond or PH bond if it is lower apart from PO bond and POH. And phosphorus also under this tends to disproportionate to higher and lower. By using this, H3PO3 can be converted to H3PO4. If you see the oxidation state of phosphorus in H3PO3 is +3, that is changed into +5. It means oxidation takes place, and also reduction takes place when +3 oxidation changes to -3. Okay, and phosphorus hydrogen bonds are non-ionizable and POH bonds are ionizable. So this is just the summary that how we obtained. We have to remember these two: orthophosphorus H3PO3 and orthophosphoric H3PO4. Now if you remove oxygen from here, you will get H3PO hypo. And now if you combine these two molecules with the elimination of water, you will get pyro. It means all three is over now. Now if you talk of orthophosphoric acid, if you add two molecules and removal of water, you will get pyro. And if pyro you remove oxygen, you will get hypo. And this phosphoric acid, if you remove water, you will get HPO3. So this way you can remember the structures of phosphoric acid and draw the structures of phosphoric acid. It will be highly beneficial and easy for you to do that. So let us take up some questions to do which is more acidic, orthophosphorus acid or orthophosphoric. You have to find the oxidation number. More is the oxidation number, more is the acidic character. And if you talk of next, name the tetrabasic acid. So tetrabasic, you know that two acids are there which are tetrabasic, that is hypophosphoric acid and pyrophosphoric acid. Okay, so you can see from here also. Here oxygen will not be there in the. If you want to draw the structure like hypo, you have drawn here now. So how to draw for pyro? You have to remove this oxygen. That's all. Okay, so it will be combined here. So next is how we can say that H3PO2 is reducing in nature, because it's having two hydrogen that is directly to the phosphorus, which imparts reducing character to the acid. Means the reducing character only, it's not that only connected with the OH, it can be directly connected to the phosphorus. And basicity of H3PO4. So after drawing the structure, you can see that here 3 OH bonds are there, POH bonds. So 3 H enable hydrogen, so basicity will be 3. So okay, so this is how we can do that. So hopefully you are aware of these answers which we have discussed. And so here again I would like to repeat the thought: face your fears. Thank you.